All right, population. The last one had population, standard deviation, population mean. This one has a nice picture of your x-axis with your sample mean, right? X bar is the sample mean. S is your sample standard deviation, and showing you the empirical rule, which was that 68% fall within 1, 95% of the data fall within 2 standard deviations, and 3 standard deviations get you that 99.7% of the data, theoretically. So that ends right there. So think about that. That's 100% of the data minus that gives you the 0.3 left on the very, very tips where it's not going to exactly touch, but there's still some space there. If you divide that by 2, you're going to get 0.15. So right here and right here is 0.15, 15% of the data there to complete to 100%. Okay. 0.15% of the data can fall theoretically above or below 3 standard deviations. So let's look at this little example here. We have a vending machine that pours soft drinks into cups. Okay, the amount of soft drinks dispensed into a cup is normally distributed. So that means its distribution of dispensing liquid into soft drinks into a cup can be shown on a continuous probability distribution X scale. Okay, and it says it's normally distributed with a mean of 7.5 ounces. And doesn't say it's a sample. It says this machine does this, so that should be all, right? So that means this is a mu of 7.5 and a standard deviation or sigma of 0.5. Okay, if it said it was a sample, you'd be using the X bar and the S, but it's all of them. So it says draw a normal distribution for the number of dispensed ounces. So the mean's in the middle. Excuse my kind of slopiness on the, it's never going to be perfect. Do the best you can. But I'm going to add 1 standard deviation over is 0.5, 2 standard deviations over, 3 standard deviations over, 1 standard deviation down, 2, 3. Okay, so I've marked it up with my standard deviations. Estimate the probability the machine will not overflow an 8-ounce cup. So remember, these are ounces. Okay, so an 8-ounce cup, everything that will not overflow is this way. Will not overflow because it's under 8 ounces. But everything that is this way will overflow an 8-ounce cup. Okay, and if you're using the standard, the empirical rule above here, you can figure out the probability of these different directions. Okay, so the chance that it will overflow between here and here, look above, is 13.5%. You add that to the 2.35%, don't write the percents in there, plus that 0.15 on the end. Okay, so on the upper end, there is a 16% chance that this machine will overflow an 8-ounce cup. So that means this is 1 minus a 16% chance, or an 84% chance that it won't overflow. Okay, using the empirical rule. So that takes care of will not and will. And then it says the machine's been added with 800 cups. How many do you expect to overflow? 800 cups, and 16% of them overflow, right? 16% comes out to 128 cups. That seems like a lot of cups will overflow using this machine. Okay?